2016 Leaving Cert Higher Level Paper 2 Question 7. This is a glass roof lantern where the vertical height is AB. Point of A is the point of intersection of the diagonals of the base. CD is 2.5, CF 3. Show AC is 1.9 meters, 1.95 meters, corrected 2 decimal places. Well, here's AC. If I continue along this line, I can create a right angle triangle that will enable me to get the diagonal, which is twice the length of AC. So anytime you're doing that, take the triangle and just do a sketch of it on the outside. We have a 3, we have a 2.5, the square root of 3 squared plus 2.5 squared. And then to get the answer for AC, AC is half of that. So AC, we can type this into our calculator. It's decimal places, so it doesn't work out evenly. 3 squared plus 2.5 squared divided by 2 equals, on a calculator, 1.952. And we're looking for 2 dp, so 1.95 meters, which we are asked to show. In part 2, you're told that the angle BCA is equal to 50. This one. Show AB is 2.3. Okay, let's draw that triangle again. So we've got our red one now. So again, this is going to be a right angle. So take your triangle, draw it again. We've got our 50. And we have the base, which is what we got in the previous part, to be 1.95. And we're looking for X, which is AB. This one here. So it's tan because we have the straight side. So the tan of 50 is equal to O over A, X over 1.95. So 1.95 tan 50 should give 2.3 meters. Let's have a look. It gives 2.326, 2.32, one decimal place, 2.3 meters. In part 3, we're asked to find BC correct to the nearest meter. Go to our diagram again. BC, what's the diagonal of the triangle we've previously used? So this is just going to be Pythagoras. So we have X now, and we have AC. So we can actually, we're just looking for, now well, let's call it Z. So Z, BC, is equal to the square root of 1.95 squared plus 2.3 squared. So this is going to give me 3.015 to the nearest meter. Okay, it's 3 meters. In the next part, we're asked to find the angle BCD correct to the nearest degree. So let's look at our triangle BC. BD is the same length, and I have CD. So if I imagine standing this triangle up straight because it's lying kind of at a diagonal on the roof. Let's stand this triangle up straight. We have a 3, and a 2.5. And we're looking for this angle here. We'll call it A. I can drop my perpendicular bisector here and create a right angle triangle. So I've got half of 1.25. I still have my 3. So I have A and H, so I can say the cos of A is equal to 1.25 over 3. So the inverse cos of that is equal to, correct to the nearest degree, 65.37. So A is equal to 65 degrees. Part 5, we're asked to find the area of glass required to glaze all 4 triangular sides of the pyramid. Well, this one in part 4, there's going to be 2 of them. This front one and the back one, and then we have the 2 sides ones, FB, C. So we have the length of these sides, they're all 3, these are 3. So we have an isosceles triangle there, 3, 3, and 3. So we have 2 of these ones, 3, 3, and 3. I could get the perpendicular height and use half the base by the perpendicular height on both of these, but we could also use half AB sin C. which means half one side by the other side by the angle in between them. These are all 60. We got this one to be 65. So I have half. I'll do the one in part 4 first. Half 3 by 2.5 by the sine of the angle in between those two sides, which is the sine of 65, equals, and then the second one is going to be a half 3 by 3 by the sine of 60, and there's 2 of each of those, so let's get these answers and double them. So half of 3 by 2.5, so that's 1.5 by 2.5 by sine 65 is going to give us 3.398. And if we multiply that by 2, we're going to get 6.797. Now this is to the nearest meter, so we don't need all of these, but 3 decimals probably till the end. 1.5 by 3 by the sine of 60 is going to give 3.897. And there's 2 of them. That's going to give 7.794. So that's 13 and 1.4. 14.4 is actually, it's going to go over the 5 with the 9, so we did need these. It's going to be 14.59, so just above halfway. 15 meters squared of glass required. Last part of this question, you're given a diagram of another roof lantern. AB is equal to 3. BCA is 60, so we're dealing with this triangle here. So we have a right angle, we have 60. Find the length of the side of the square base. Okay, so we need to work our way out. We're looking for the length of the square. So let's just deal with the triangle that we have first. AB, 60 down here. And we're told AB is 3. So what can we get here? We can get, if we get this side, it's like the reverse of the first question, and then double it, we have the diagonal. And then these are both x, we only have one unknown, and then we have the third value of the triangle. So that's the root into this question. So we need to get the base here, CA, we'll call it y because we call the other one x. So it's tan, because we have the two straight sides, tan of 60 is equal to 3 over y, O over a. So y is equal to 3 over tan 60. And the tan of 60 is root 3, so 3 divided by root 3 is root 3. So y is equal to root 3. So now I'm going to just change colour and draw the next triangle we're dealing with. So we're going to deal with this one, where we now have the diagonal as twice root 3. So I have my diagonal is 2 root 3. And I have my square sides, which are x each. So Pythagoras, x squared plus x squared is equal to 2 root 3 to be squared. 2x squared is equal to 4 by 3. 2x squared is equal to 12. X squared is equal to 6. So x must be the square root of 6. So a good trigonometry question in 2016. Loads of different types of triangles. Always draw each individual triangle rather than trying to extrapolate your information from the diagram given.